Private clouds, like other cloud deployment models, also must adhere to cloud computing characteristics. When we talk about a private cloud and characteristics, we're talking about things like resource pooling. In this case, the resources would be owned and acquired by a single organization and made available for private cloud use. With the private cloud, the broad access cloud computing characteristic is a little bit different than it might be for a public cloud. With a public cloud, we're talking about allowing access to anybody over the internet, potentially, if they want to sign up with an account, with the public cloud service provider. With a private cloud, broad access here is more limited than it would be with a public cloud. It still means accessing IT services over a network, but that network is controlled by a private organization, such as a local area network. It could be a wide area network, depending on if there are site-to-site VPN tunnel links linking offices together. Broad access, of course, also means access from a variety of different types of devices. The use of private cloud resources is tracked, usually for the purpose of departmental chargeback. So even though it's a single organization because it's a private cloud, each department might pay, for example, a central authority like the IT department for the use of private cloud resources. Rapid elasticity is still possible with the private cloud, the quick provisioning and deprovisioning of cloud resources as needed, and of course, self-provisioning, the last cloud computing characteristic, would be available in a private cloud too. This might be done, for example, with a web-based interface, whereby cloud users could perhaps select a template to deploy virtual machines within the private cloud. So private clouds then do use virtualization. You need to have virtualization to have any type of cloud. But the fact that you're using virtualization on premises, that by itself does not mean that we have a private cloud. If you've got VMware ESXi hosts running virtual machine guests, that's not a private cloud. But if you couple that with the other cloud computing characteristics that we've just gone over, then you would have a private cloud environment. So virtualization is required. So we know that a private cloud then is owned and used by a single organization, and that's why it's called private. This means that the organization then has full configuration control of all of the IT services available in that cloud computing environment. It's a single tenant environment is really what it is. And we know that it uses virtualization. We know that we can have metered usage or tracked usage for departmental or even chargeback to specific projects within the organization. Organizations might require full configuration control of their cloud computing environment for regulatory compliance. So it depends on the nature of the business that the organization engages in. With a private cloud, we have LAN and WAN bandwidth isolation. We know that a private cloud is accessible only to a single organization, and that could be locally with a local area network, a LAN, or, as we've mentioned, if we've got different branch offices linked together over the internet, perhaps through site-to-site VPN tunnels, we could still have a single private cloud just spread across different locations through a wide area network or a WAN. But the key about this is that it's a private cloud that is owned and used by a single organization. This means that full configuration control is possible for the organization because they own and run everything for the private cloud. It also means that there needs to be careful consideration of on-premises security to ensure that physical security measures are put in place to protect the actual equipment running private cloud resources. So server rooms should be locked. Even individual racks housing rack-mount equipment like servers and storage arrays and UPS devices, all of that should also be locked. The other thing to bear in mind is that all of the responsibility for complying with security standards and various regulations that deal with data privacy and things of that nature, all of that responsibility falls on the organization. So the full responsibility for data privacy and security, for the underlying cloud infrastructure, that means making sure that we've got power to support all of the computing devices, backup power ideally, having the proper HVAC in place to keep equipment cool and running smoothly, having the equipment patched at the firmware level, making sure that there's some redundancy even at the network level. All of that is the responsibility of the organization because they own and run the cloud. Now, you could also say that from a security perspective, a private cloud would be considered less of a target than a public cloud, because public cloud providers are advertised, everyone knows about them, and that might be true, but at the same time, remember that a private organization probably doesn't have the resources that they can dedicate to securing the infrastructure like a public cloud provider could, due to economies of scale, having thousands upon thousands of cloud customers. With a private cloud computing environment, we know that the organization owns the network. They own perhaps a data center if it's a large enterprise. And there are solutions in the Microsoft Azure world, such as Azure Stack, that can be used for an off-site data center. Azure Stack basically lets you run Azure services on premises without having a connection to the public cloud at all. That might be useful for isolated air-gapped networks or even on ships and so on. The other thing to bear in mind with private clouds as a final parting point is that the management of the private cloud does not have to be done by the owning organization. That can be outsourced to consultants that might have expertise working with Microsoft Azure or whatever the private cloud solution is, if it's not Azure Stack.